Welcome to 7.5, everybody. So 7.5 is continuing with function stuff, and in this section we're going to be graphing two different functions called the square root function and the cubed root function. So it seems a little random compared to what we were doing before, but it's still working with functions, which is why it's in this chapter. So I want you to know that what I'm going to show you next are two things called the parent functions, the parent function for the square root and the parent function for the cube root. Our method today is we're going to take the parent function and just move it. So we're going to take the parent function I'm going to show you and then translate it. So the square root graph, the parent function is y equals square root of x. So that's our regular function, no translations. And now in order to graph it, I'm going to show you a table of values for this first time. When we do our graphs, our real graphs, we're going to just translate this though, so that we don't have to make a table of values every time. Alright, so let's say I'm going through here. I'm trying to find some x's and y's. Maybe I don't really know what I'm doing, so I start out with x. I'm thinking, okay, I'm going to try x is negative 2. Oops, not possible, because I can't take the square root of a negative. So I'm going to start with 0 then, and y is square root of x. So every single time here you're going to see me put whatever I put in for x underneath a square root. Alright, so my first dot is 0, 0. Next, we'll just do a few here. Okay, up through 4. So the square root of 1 is 1. Cool. So 1 comma 1 is my next dot. The square root of 2 is 1.4. So 2 comma 1.4. Just do your best, kind of approximate it. Square root of 3 is 1.7. So 3 comma 1.7. Again, just kind of do your best to approximate it. And then last but not least, the square root of 4 is 2. And so this is my graph. And notice it started at 0 because I can't have any negative x's because I can't have the square root of a negative. With our graphs today, we are going to be talking about the domain and range. So you know how I just said I can't have any negative x's? So my domain can't be negative, so it can only be 0 or greater. So I'm going to say for the domain, x is greater than or equal to 0. And this is for the parent function domain. It's going to change when we move it. Our parent function range is the y's. Alright, to think about this, I want to say what possible y values are used in my graph. And if you look at this, y does not go below 0. It's just at 0 and above for the y's. So my range is also greater than or equal to 0, but I'll say y. Y is greater than or equal to 0. Alright, so that's one of the two graphs we're going to do. The other one we're going to do is the cube root function. So y equals the cubed root of x is my parent function. And notice for a cube root, we actually can take the cubed root of a negative. So when I try to start with negative 3, for example, it is going to be possible. And every single time, just like we did before, my function rule is the cube root of something, so I'm just going to plug in what x is and use my calculator to evaluate. So I use my calculator, and the cube root of negative 3 is negative 1.4. So my first dot is 3 comma negative 1.4. Again, just do your best to approximate that. And I'm going to keep going here. So cubed root of negative 2 is approximately negative 1.3. The cubed root of negative 1 is negative 1. Cubed root of 0 is 0. Cubed root of 1 is 1. And these are now just repeating the pattern. Cubed root of 2 is 1.3. Cubed root of 3 is approximately 1.4. Alright, so it looks something like this, and it would go slightly higher and slightly lower as time goes on. So for my domain and range this time, again, think back to what we did in previous sections. The domain is what possible x values can I use? What possible x values can I use? Well, I don't have an even root, I don't have any fractions, and that means all x values can be used. And another way of thinking about it, if you look at the graph, this is continuing to the left and to the right, and if I was going to make the world's largest graph, eventually this whole span of x values has been used. Every single one of them would be used. And the range is kind of hard to see on this one, but the same thing's happening. Even though the range it's kind of, for the y's, it's kind of increasing very, very slightly, but it's still increasing and increasing and increasing, and same thing here, like it's decreasing very, very slowly, but it is decreasing. So if I was going to make the world's largest graph, eventually all of the y values would be used. So y is also all real numbers. Now let me give you a little hint. For the cubed root graph, because it's always going to be this shape, the domain and range for any cubed root graph is going to be the same, all real numbers, all real numbers. That does not apply to the square root graph. The square root graph is going to change depending on where it moves, but the cube root graph, the domain and range will always be all real numbers. Alright, so our method today is we're going to just take those parent functions and move them. So I'm going to have the exact same graph, just translated up, down, left, right, and it could be possibly stretched or shrunk. So if you look at a formula they're going to give you, or an equation they give you for a cube root or square root graph, based off of where there are pluses and minuses, we can figure out if it's going up, down, left, or right. So for example, underneath the square root, if you see a minus sign for that value, it moves it to the right. If you see a plus sign for that value under the square root, it moves it to the left. For the k value outside the square root, if you see a plus sign, it moves it up. If you see a minus sign, it moves it down. I just want to throw out there that the left and right might have been the opposite of what you expect. Keep that in mind, but then the up and down is just as expected. The value in front stretches or shrinks our graph. And actually the same rules apply for both of these. I just wanted to write down both of the functions so you would know what it kind of looks like if it's cubed root. So you can rewrite it if you want to, but you don't have to. Alright, so for the first example here, we're just going to describe some translations. So I want to just know, how has this moved? Up, down, right, left, right. So let's just get the hang of this quick. So look back in your notes if needed. Underneath a square root, I see a subtract sign. I go back to my notes. Okay, underneath the square root, subtract sign means right. So I'm going right 3. And then outside the square root, I see a plus sign. Go back to my notes. Okay, plus sign outside means up. So this graph is translated right 3, up 4 from the original. Next one. Now I see a plus sign underneath, so that one is going left. So that one's going left 6. And now I see a minus sign outside. Look at my notes. Okay, so this one's going left 6, down 9. Pause really quick and try the next two. Look at your notes as needed. Just see if you can do it. Okay, if you have unpaused, here's what you should have for answers. The third one is left 3, up 8. And the fourth one is right 5, up 1. Flip to the back. Alright, so the first two graphs we're going to do on the back side is just translated from our original. There's no stretch or shrink yet. The stretch or shrink is by far the hardest thing you can do, so we usually always start with just the up, down, left, right. I would recommend that you always figure out what the transformations are first. So figure out how our graph is moving. And here's what I mean. Our parent function, if I was going to pick 3 critical points for our parent function, it would be 0, 0, 1, 1, and 4, 2. The other points were kind of decimals, so I didn't care about that. So that's our parent function, square root of x. And what I'm telling you is we're going to take that exact function and just move it. And I'm going to look at this and say, okay, according to my notes, I see a subtract sign underneath, so subtract sign underneath means right, so right 3. And then I see a subtract sign outside, that means down, so right 3, down 2. And to get our answer graph, we're literally just going to take every single point and move it right 1, 2, 3, down 1, 2. So right 1, 2, 3, down 1, 2. Right 1, 2, 3, down 1, 2. And that is our answer graph. Graphing the parent function is optional. You only need the one I just graphed in red to get full credit, but I recommend you graph the parent function just because it really helps out. We're supposed to also state the domain and range right now. So I just want to point out that normally for a parent function graph of square root, the domain was greater than or equal to 0. Remember that? And the range was greater than or equal to 0. The domain and range have just shifted with this starting point. So now this graph starts at 3. Really, the domain has been shifted right 3 is kind of how you can think about it. So the domain is now greater than or equal to 3 instead. And if I think about my y values, the range has now moved down 2. So instead of starting at 0, my range starts at -2. And there I go. So I got my graph, and I got the domain and range for my final answer. All right, we're going to do one more for this part 1 video. So this time my graph kind of goes off what I gave you a little bit. That's okay. 1, 2, 3, 4, up 2. Okay, so that's my parent function. And this time my translations are left 7, up 4. So I'm literally just going to take my 3 parent function dots and go left 7, up 4. And again, we just skipped these middle dots just because they're kind of decimals and hard to graph. These 3 dots were exact points, so they're easy to graph. That's why I chose those 3 points to move from the parent function. Okay, so I'm going left 7, up 4. 1, 2, 3, 4. There it is. Okay, left 7, up 4. Left 7, up 4. From the original, and there it is. So that is my answer graph. And for the domain and range, again, they have just shifted with my graph. So the domain, now the x values, has started out at -7. It's moved left 7. So I'm going to say x is greater than or equal to -7 now. And the range has moved up 4 units. So the range is greater than or equal to 4 right now. I'd say finding the domain and range is very tricky, so that's something that we're definitely going to have to talk about some in class if people need it. Hey everybody, welcome to 7.5 Part 2. So we're going to continue working on our square root and cube root graphs. And on this side, we're going to continue to work on translating, but now we're also going to have a stretch or a compression with our movement. So and one other thing I want to tell you is they're not always going to have it in square root form because a 1/2 exponent is the same thing as a square root. What they've given us for example C is really the -3 times the square root of x plus 3 in disguise. So if it helps you out, just rewrite it first, then try to graph it. And now I just want to point out as well that I only put the square root around the x because that was the only thing that it was with, because there's no parentheses. But in this situation, whatever is in the parentheses goes underneath the square root. Alright, so when I start out this way, I'm going to start out the same way we did examples A and B. So I'm going to graph my parent function, and this never ever changes because every single time we're graphing the graph, y equals square root of x. And again, we picked these 3 points because they're specific dots that are easy to move. So every single time I'm starting out with my parent function. Now, to do this graph, the first time I teach you this, I'm actually going to teach it in 2 steps, but when you get the hang of it later, it's okay if you do this all in the same step. So here's what I'm going to do. I'm going to actually first graph the stretch before I move my graph. And the stretch or compression comes from that a value, the a value that's in front of the square root. So right now it's a -3. So here's what I gotta imagine. Normally my graph was 0, 0, 1, 1, 4, 2. That's just 3 of the points on my parent function. What happens here is that now I'm putting a -3 in front of the answer, so each one of these basically is multiplied by -3. So now that's still 0, that's now -3, that's now -6. So 0, 0 is going to stay where it's at. The next point goes down to 1, 2, -3 instead, and then the third point goes down all the way down to -6. So this is my graph right now. I'm just in the intermediary step though. I'm not at my final graph yet. But I just want to pause a second and make sure that this makes sense. Sometimes students don't really use a chart. One thing you can think about is that number in front, it's kind of like slope. There's technically not a slope for a square root graph, but if you want to think about it like a slope, that's a good way to think of it. So instead of having, this would be maybe my normal slope, and now instead of going up to 1, I'm going to go down to 3, and then instead of up to 2, I'm going down to -6. So basically what I've done is I've taken the y value of each of these and multiplied by -3. So you multiply the y value by -3. Hopefully after example D and then a few more with the cubed root, that'll become more clear to you. Now that I've graphed the stretch, I'm going to, in step 2, graph the translation. And when I say translation, I mean up, down, left, right. So at this part, you guys are pretty good at this by this stage. I look at this, it has a plus sign, it's outside the square root, so in my mind I'm thinking up 3. So that green graph we just created, I'm going to take each one of those points and move it up 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. And then that, in the red, is my final answer. So again, like I said before, these intermediary steps are actually not required. Only the final answer is what you need to get full credit. So if you want to cut out one of the steps or both of the steps, you can. But if you're someone who's struggling, I would recommend that you do all 3 steps to get your graph. We need to do domain and range for this. And if I look at this, remember I'm looking at where my x's and y's go. So this time my x values are starting right here, so that actually hasn't moved left or right at all. So the domain is the same as normal. But the range has moved. The range, it's moved up 3. And then also, it's not going above the line right now, it's going below. So it's not actually values larger than 3, now it's values below 3. So I'm going to say y is less than or equal to 3. Notice how this is not anything that we've done yet before, so that's new now. It's less than instead of greater than. Alright, for example D, I'm going to do the same process. So step 1, I'm going to graph my parent function. 0, 0, 1, 1, and 4, 2 are the 3 critical points for my parent function. I am going to first graph the stretch or compression. In this situation, I've got a 2 in front. So again, remember how I said you only multiply the y values? Basically, all of the y values get multiplied by 2. And for a lot of you, it might be more clear when we're starting out here if I put it in chart format. So again, here is my parent function. What's happening is I'm just putting a 2 right in front of that square root. So everything I had for my answer before now becomes times 2. And these are my new y values. So again, the x values stay the same, just the y values change. So it still starts at 0, 0, but instead of going up to 1, it goes up to 2. And at the next point, instead of going up to 2, it goes all the way up to 4. And I have not done any of the translations yet. All I did is the 2 in front of the square root of x. Alright, now that I've done that, now let's move it. So, I'm looking at my up, down, left, right, and I gotta consider what's happening here. When I look at this, looking back at my notes if needed, I'm thinking it's going right 1 and up 1. That's easy, so I'm going to take all my green dots and go right 1, up 1, right 1, up 1. And draw on my new graph. And so this is my answer graph. And we will find the domain or range again. So, finding the domain and range, remember, basing it off of where the red graph starts. So my domain, this situation, my x value did shift over, so now my x is greater than or equal to 1, and for my range, that also moved up 1, so and it's above the line, so its values greater than or equal to 1 for that range. Please pause the video and make sure you get all that down. Sorry, I'll scroll up for a second. And then when you're ready, we'll move on to the cube root graphs. And we will do lots of practice graphs in class in case you're wondering, because for a lot of you, 2 examples of the tricky ones might not be enough. Let's move on to the cube root graph and we'll see what happens with that. Alright, so again, I've got a parent function that I'm going to translate. And now for the cube root graph, we had put a bunch of different points on our sheet. Flip over to the front quick if you want to look at our parent function. Again, I want to pick some critical points that are going to be easy to graph and translate. And when I look at the cube root graph, the ones that are the easiest to graph and translate are 0, 0, 1, 1, and -1, -1. All the rest of them are decimals. So just these 3 points I'm going to use for my parent function every single time. So your answer graph will also just have those 3 points just moved or stretched out. So that is my parent function. And now, remember, same rules apply. So if it's outside the square root or cube root, it's up or down. If it's inside the square root or cube root, it's left or right. So I've got an outside 4, and it's positive, so I'm thinking up. And that means each of the dots I decided to use from my parent function, remember, it's the same graph on the front, I just didn't graph all the points. I'm going to move each of those up 4. All right, here I go. I'm moving each of them up 4 and graphing in my new graph. And that's it for my answer for that, and then we got to do domain and range. So you may or may not remember this from the front of the page, but remember how I said for a cube root graph, the domain and range are actually always going to be all real numbers. The reason is, if you look at what's happening here, there's no starting or stopping point for the x's or the y's. So notice there's no like definitive point where I can say this is where the graph starts. No, it's infinite. It's going in either direction to infinity, and also it's going up very slowly, but eventually it's going up and down to infinity as well. So what that means is the domain and range are going to be all real numbers, and even though the graph is shifted, it's still all real numbers for the domain and range, because there's an infinite amount before and still an infinite amount. All right, why don't you pause and try F on your own quick. If you have unpaused and you're now watching, here is me graphing in my parent function. Again, I'm using -1, -1, 0, 0, 1, 1. There's my parent function. And I hope that you identified this time, this is underneath the square root, so I'm going left 4 this time. All right, so every point is moved 1, 2, 3, 4 units to the left. Here I go. There is my answer graph. And again, it's not required to graph the parent function, that's optional. And like I said before, domain and range are going to be all reals for any cubed root graph, because it's going to infinity in both directions. All right, now we have the joy of doing the ones with the stretch or compression. And again, I want to tell you that they're going to try to trick you, but you won't be tricked, because you guys know this. If it has a 1/3 power, it's really the same thing as a cubed root, so don't let that throw you off. All right, like we did before, I'm going to do the stretch first, and then we will do the up, down, left, right shift. So I will start by graphing my parent function. And it's even easier to do a stretch and shift with a cube root graph, actually. So here's what's happening here. The 1/2 in front means instead of it going up to 1 and down to -1, it goes up to 1/2 and down to -1/2. And more specifically, if thinking about that chart really helped you from before, here's my parent function. Here's my parent function points I'm using. And now when I stick in front of that a 1/2 times the cubed root of x, I'm just taking each of these and multiplying by 1/2. And then these are my new y values. So again, the shortcut is just instead of going up to 1, go up to whatever the a value is. So this time I went up to 1/2. All right, I'm ready to do my up, down, left, right shift. So by now, I hope this is becoming kind of automatic for you. I'm thinking right 2, up 4. So right 2, up 4, right 2, up 4, right 2, up 4. Be careful, make sure that that only has that a value of 1/2, and that is my final answer. Domain and range, all reals. If you feel up to the challenge, try part H on your own. Okay, here I go with part H. So again, I'm going to graph my parent function first. This time, my a value is a -1/3. So here's what I want to think about. Instead of going up to 1, I am going to go up to -1/3. Wait a second. up to a negative a third means I'm actually shifting it down. So when you have that negative in front, it actually shifts which way the little curve is going. So I took that point, and instead of going up to 1, went down to negative 1, and I put that point in a negative times a negative is a positive third, so there I go. So it basically rotated it, and it's now only going down to a third. Okay, now thinking about this translation, I'm thinking left 1, up 1. So I'm going to take my green graph and go left 1, up 1. Left 1, up 1. Left 1, up 1 for each of the points. Alright, left 1, up 1, left 1, up 1. I'm going to draw in my graph. It's getting a little tight, so I'll just write answer. And then again, domain is all reals. Range is all reals. Please pause and go back and write down anything that you may have missed. And then again, we're going to do a lot of practice of this in class. So thanks for watching, and talk to you soon.